Alright, so this tutorial is going to be kind of long and tedious. I'm not going to really edit it in terms of speeding things up and trimming, but it is it's a very important thing to know how to do if you are interested in recreating molds or objects from scan data. So I usually do this pretty much on every part, but not to the extent that we're going to do it on this, because typically for me is I focus on mounting points and then I design my own elements. But here, my buddy Nick from Boise Carbon, he's going to be making these RCF engine covers, and he was originally going to do it the traditional way, and we're just going to 3D print flanges for him to do that, so that way he didn't have to use um, board, like poster board. However, after he was looking more and more into the part, the top surface would require a lot of sanding to make it smooth because it is very textured. So he asked if there's any way we could just 3D print the actual mold, the whole thing. And of course, that's where it requires to be created in 3D. And I figured it could be a good tutorial as well as help him out. So it's kind of like a win-win. So anyhow, I am using 3D Studio Max 2024. There is a indie license available that you could buy. It's about $305 a year, so it's not the cheapest program, but I think you could do this with really Blender as well, which is free, but I don't use it, so I can't say that's true. But I think it should be also possible. Just you got to learn where the buttons are and whatnot. So anyhow, what I'm going to do is use the scan data and model on top of it while at the same time snapping to it. So that way I am recreating it so I could 3D print my own very smooth, very simple version of it, but I'm also making it match the OEM version. So what I did here is I started doing just the edges simply because it's very boring, very tedious, and while important information, I'm going to share that information with working through the rest of the part. So it's not like you're going to miss out on anything except a waste of time. So in 3D Max, when you open it, there's going to be a lot of windows open. I usually like to clean up my workspace. This is opinion based on what you like to do. So if you're going to use this program just for making molds, kind of like well, I mean, I use it for work too, but for my mold making, I use it just like this. So first thing you're going to do is you're going to select, um, well, in your case, you're going to create a plane. So on the right, there's going to be a Create tab, and under Geometry, click Plane, and just create a plane anywhere in the screen. For length segments and width segments, do 0 and 0, or 1 and 1. Now I'm going to right-click, go to Convert to Editable Poly. Now your window changes. It's a different UI, and what we're going to do here, and I'll actually, let me move my screen over so that way I could capture the whole working area. There we go. Okay, so now you can see exactly everything. So over here, there's vertices mode, edge mode, border tool, polygon, and element. And these are the different ways to select the actual object. So the vertices are the dots, the edges are the edges, and if you press F4, you can see like a wireframe mode, and here it shows it off better. Border tool is literally the outside border of all the edges that's not closed off. Polygon is a poly, separate, and then element mode is all the polygons at once. So for example, see how this line is an edge? That means each one of these is a different polygon. So we have this one and this one. If you choose element, it selects all of them. So a quick little overview, and I know this is very boring stuff, but for an average like new user, this is important. So I'll probably add some chapters in YouTube so you could skip through it. But here are the basics of modeling. To create a new edge, or extrude it's called, if you hold shift and then drag, it creates new edges. And so as you can see, now we're creating a 3D object. Now there's a modifier, and I have hotkeys for all these, but it's called Turbo Smooth. And when you apply it, what it does, it adds a lot more edges and polygons. At the same time, it smooths and deforms the shape. So something that had aggressive corners is now getting rounded corners. So I use Turbo Smooth all the time. Now what I like to do is model simple, kind of like this, and let Turbo Smooth round it off. So that way when it comes to making the mold, I don't have to work with a bunch of edges. I could work with a lot less, make it very easy to like move, smooth, all that stuff, and then let Turbo Smooth really take it to the next level of smoothness, of subdivision. So anyhow, that's that. So to model on a surface, this is kind of where we're going to start getting to the point. So over here, you have this drop down arrow. If you click on it, it opens up a bunch of crap over here. What we're going to want to do is go to the Freeform tab right here. Then see where it says grid, there's a little arrow drop down next to it. You're going to click on that, you're going to click draw on surface, and then you're going to pick your 3D scan. So you're going to have to click pick and pick your 3D scan. So it should have your name of the thing. So for example, if this was named scan, it should say, so draw on surface, pick, scan. So that's the name of the geometry that you're going to snap to. That's essentially it. So what we're going to do is go to vertice mode, just so I could see the vertices. Now, what we're going to do here is click the extend button. And if you hover over it, it's going to give you all these shortcuts. So like shift and drag is to extend an edge. Then control shift is to like loop the whole thing. Control alt is to between edges. So there's like tips and tricks right here. And you can just experiment and you'll see how it reacts. What I usually do is I hold shift, and then when you drag, if you drag on top of the surface, as you can see, it's conforming to it. And then if you want to reposition a vertex, you do Control, Alt, and Shift. You hold it, and then you click and move. And as long as you're snapping, it literally moves it on top of the geometry. So this is how you could retopo in very simple, because you can see this has a bunch of little polygons, vertices. It's a mess. It's how normal scan data is. And what we're trying to do is recreate it in as simple of a flow as possible and then subdivide it using the Turbo Smooth modifier. So I did that with these edges. It was a very annoying, tedious process, but it is important to do. So now what we're going to do is, if you were to do this just like that, you have your edges slayed out. So now I'm just going to Control Shift and drag these vertices to kind of like snap them a little more. And now the way the Turbo Smooth modifier works, the closer your polygons are together, the more it's going to control the shape and be locked into the shape you make. The more spread out it is, the more it's going to kind of guess of how to smooth and subdivide, and you're not really going to have a precise geometry. So what I usually like to do is sharp corners, kind of model them sharp, and then for things like this that are flat, I try to minimize it as much as possible, so less of a headache. So now what I'm going to do is hold shift and drag up right here, and then hold shift drag, hold shift drag, shift drag, shift drag. And now if I press F4, I could see this. So now as you can see, it's snapping and it's perfect. However, I don't like this. It's too perfect for me. So what I'm going to do is undo all that. See where it says offset? So what I'm going to do is just put in 0.1. And now if I hold shift and drag, as you can see, we're offsetting on top of the surface a little bit. And since we are making a mold, if you think about it, the little offset helps, because then that's where the fiber or the carbon fiber is going to lay down and add the shell or the depth to it. So it's not a bad thing to offset it. And then that way you could also see it a lot easier what it is you're modeling. So 0.1's nice. I'm probably going to go up to 0.25 and see how that feels. So that to me is pretty good. So now all I'm doing is just modeling away. And I mean, this is a very boring, tedious process, but you gotta do it. So here's some like little tips and tricks along the way to help speed things up. So as you can see, I left these pockets open. If you go to the edge mode and then you click this bridge button, you could literally click on the two edges from one to the other and it will create the polygons for you. So now if you turbo smooth it, as you can see, we're starting to get the shape. Now, the one thing you notice is when we turbo smooth it, this is where you want to test things. It's making the object go through the mesh, which means it's no longer accurate to what we have in scan data. So that means we have to add another edge right in here to kind of force our own shape. So what you want to do is, I know I have a shortcut for it. Here we go. This button, Swift Loop, it's amazing. If you click on it and then you kind of like hover in the areas, you can see there's like a little lime green line. This creates kind of set of edges all across the inner edges. So if I click on that, and now I go back to freeform, extend, and now Control Alt Shift, and just click on this. As you can see, we just added the edges, and we repositioned them to kind of match the curvature of the scan data. So now I'm going to turbo smooth again. As you can see, this is feeling a lot better. If you really want to avoid this kind of penetration, all we want to do is go in and add one more set of edges. And I just did Swift Loop, but hotkey for myself is custom, so I just added it to be a V. This is all personal preference. But as you can see, now I added 3 rows of edges. And if I turbo smooth it, as you can see, a lot less penetrating. So I might just do a time lapse at this point, because that in a nutshell is the process. After this, all it is just kind of doing the same repetitive thing but watching your flow. So okay, so as you can see, sometimes it'll like randomly create an edge, and that means it's accidentally grabbing an edge from here and trying to move it over there. What you can do is, if you want, you could isolate half of the geometry. Well, for you, you won't have it, but if you did, there's these hide and unhide things. So if you have this selected, click hide unselected, and now you'll just be working with what you have selected. So that's one way to do it. Me, I usually just undo and try again, and that seems to kind of like a quick little fix without having to hide and unhide. So see that again, it's snapped again. So I just rotate the angle of the camera a little bit, and for me to do that, I hold Alt and press down the center mouse wheel, and that allows you to quickly rotate. So I'm just gonna go do that. Just one more edge, and see, the trick is to kind of hold these shapes as natural as possible, kind of manually create them instead of thinking that they're going to do what they're going to do. Now, see how right now we have 2 edges, and I want to extend all of them. If you do Control and Shift, it'll extend every kind of selection, if you will, the whole selection. So I'm just going to go do that. Now I'm doing Bridge tool. For me, it's a shortcut. Bridge, bridge. There we go. I'm going to go back to extend. I should probably, with as much as I model these things, create shortcut for extend as well. But that's all it is just manually going in and creating edges and moving edges. So extend, that, then bridge, bridge, bridge. And because we are working on top of the scan data, a lot of times the surface will look good and smooth without kind of like bumps. But if you're modeling from scratch, that's when you actually do have to learn about topology and how to create smooth models. And that takes a lot of practice. It's a skill of its own that takes years to really get good at. So the Retopo is a lot easier than creating a brand new model from scratch based on your design. So see, this is just, to me, very annoying. So I might end up just hiding the part. So the reason why I'm doing this one alone and not doing a loop, because it'll extend this one. So for me, it's just, all right, so see, I have an edge right here. I could either remove it from down here, like so, or I could have cut into there. So for the moment, I'm just going to remove it, and then I'll just take this one, extend it out. Target weld allows you to click from one vertex to the other, and then I'm going to bridge that like that. All right, let's see what's happening. So It's not too bad. So I'll leave it as is for the moment. But again, if I wanted to keep a more true thing, I would add edges there and there, and then it would have a really like kind of crisp corner to it. So see, when I remove it, it smooths it. So, and this is where it's kind of like based on what you're retopoing, how complex it is or how simple it is. But this is in a nutshell the basics of, okay, see how this is just very, very annoying? So if I just go like this, hide unselected, there we go. I'm not going to have this issue anymore. So now I could just go at it. And typically what I'll do is keep it simple in the beginning, just like you saw, where I'm really just sending it and extending the shape. And I'm going to like focus on the more complex areas. So here we go. So now what we're getting into is a triangle. With 3D polygon modeling, polygons are key. If you get triangles, you get this thing called pinching, and that creates kind of like a bump within a corner. And sometimes you get away with it, sometimes you can't. Because we are 3D printing our molds and sanding, that's where we could fix things in post, if you will. Especially like with me, I'm adding primer. So this is very forgiving for us. But in 3D world, if you have a pinch, that's a no-no. So for the moment, what I'm going to do is I'm going to extend this down, take this edge out, then I'm going to extend this one out, and we'll see how this comes out looking. So I am just going to go something like this, because the trick is to keep it as simple as possible. That way straight lines and edges are a lot easier to kind of keep. So I'm not mad at that. That's not looking bad. So now we're gonna go extend this. Then here I'll just extend this one all the way out here. Connect those two. Let's see what this is looking like. So see, the trick is to kind of like assemble a puzzle. That's what this kind of is. So here's what I can do. I could either add more lines here, or to keep everything in quads, I could fill it in just like that and see 4 points, 4 points, 4 points, and we just closed off a area while still keeping the geometry clean and not creating more edges to work with, because the more you have to work with, the more of a pain it becomes. So now I'm just going to extend this one there, bridge there. If you hold Alt and press X, you can do like this X-ray mode. So sometimes I do turn it on. So as you can see right here, we're not staying true to the design. So what I'm going to do is just snap right there, like that. And that's also the key here, is to pay attention to what the actual scan data is doing. So now what I'm going to do is kill this corner like that, so I don't have to keep it going all the way. So I can make this very simple. And the more simple you keep it, the less risk you have of like surface imperfections. So there we go. Smooth that out. And see, that's looking really nice. We got our little design curve, our corner, everything's going well. And this is this is what I like to see when I'm modeling in general or retopoing. You keep it simple but still detailed. So here I'm just gonna snap it a little bit, because again, we have the real CAD data or scan data, so it's okay to snap to it because it's a good representation of what the real surface was. Now if you have a car that's crashed, yeah, your bumper is going to be all messed up and not true to what it should be. Then you're going to have bumps, but those are not the bumps you even should be worried about. Those are real issues with the geometry of a vehicle. So there we go. As you can see, this is nice. And what I'm doing is I'm rotating around, paying attention to the highlights. The highlights in 3D are also a very good way to see if there's bumps, because if you had a surface flaw, you would literally see the shade change. So that's how I kind of inspect my mesh, is looking at how the highlights change based on the curvature. But again, checking the highlights and understanding what you're looking at is one of the other things that just unfortunately comes with years of modeling. And I've been modeling, I don't know, since about 2001. So it's been a long time that I've been doing this stuff for. So filling that in. Now I'm just gonna see if I get away with the triangle. I hate triangles, but because this is scan data and we are 3D printing this, this is where if there was like a pinch, you could just sand it smooth, especially because you are gonna sand, or I sand and resin coat my 3D prints anyways. All right, so now I'm just gonna connect this one more time. Go in and snap it to the scan data. As you can see, it's slightly changing the shading, which is fine. So here's the only thing to think about. See how we have these edges fairly close? The smoothing of this bend is going to be crisper over here and rounder over here. And that's where your like shade changes. So see how like right here, this highlight has a like a confined highlight, but then here it's not really present. So this is where you might want to go in and just more or less try to create edges to flow at the same distance as that one, and then as soon as you don't need it, you could kind of kill it. So I'm just gonna adjust that, and what I'm doing here is just using this edge constraint. So under edit geometry, under constraints edge constraint, what it allows me to do is move these vertices, but it only moves them based on the edges that are already present. So this is how you could keep it still natural to the like placement of the scan data, but also be able to move things around. So now, if I bridge this one over, if you look at the highlight, see how now it spreads and it flows? That's what I want. And it might be overkill because again, once you 3D print it, you could fix a lot of issues just with sanding. But if you're already doing it, it's a quick little couple minute change. It just makes it a little better. So there we go. That is modeling the pocket of it. And unfortunately, we got the rest of the engine covered to do. So I'm just gonna work through this. I'll probably stop the video now, and if I run into any areas that are kind of important to share information of, I'll share. But I guess what I'll do is just one other thing is I'll get this little detailed corner going, and after that I'll just stop. So as you can see, I'm moving this vertice to this corner. I have a few of these edges here just to get this little pocket. Now I'll keep it because again I could remove it later, but for the moment I'm just going to keep that detail. So here we go. I'm just gonna, and usually for bevels and edges like this, I like to keep it in like three sets of vertices, 2 edges. So now I'm gonna go here, here, and right there. So as you can see, what I did here to create this little transition in curvature and like flow is I ended up having to create a kind of like a triangular like polygon of its own. So then I'm going to go out here, and this one's going to be a lot easier. And there we go. As you can see, we have that. All right. And now I'm just going to hold Control Shift. Oh, I got to do extend. So I'm holding Control and Shift and just dragging. What the hell? Oh, I see what's going on. So Control Shift and just dragging all sets of these. As you can see, we're getting a lot of penetration happening, like from our poly to the scan. So that's where we're going to want to go back and kind of add a little bit more detail from the personal modeling stage. And again, curvatures like this, you want to manually add in the detail, otherwise it won't stay true to the actual scan. So like that, and that's what I usually pay attention to, is how much of a penetration am I getting? Because see, if I go all the way out here, that means we just broke the total design lines of the OEM part. So just kind of going through it. And this is all it is just drag, extend, look, drag, extend, look. And yeah, so I'll just take a preview, see this. Yeah, I'm just going to manually add a set. Move these kind of right here. Then snap these out here. There we go. See, now we're not getting any penetration from the scan and the model that we're creating. So I'm happy with that. It means we are staying true to the OEM design. And then what I'll do here, same kind of deal. So for a quick edit like this, what I'll do is just extend two of them independently. Select these vertices, and then there's a button that's called collapse. I have it as a shortcut, but it just literally collapses the selection. So now I'll just do this, and now I can just go in and quickly start extending these lines. Again, pay attention to how much it's penetrating the original data. Yep. As you can see, that this area gets a lot more of a curve than the outside, so we have to add more edges on our own. So now what I'm going to do is kind of go from side to side and create a bridge. And yeah, I'll show one more trick before pausing it. Okay, so let's say you have this, right? And now we have a bunch of stuff in the middle. And okay, so we're going to go and we're going to create an edge here, an edge here, an edge there, an edge there, and one more right there for the moment. I'll actually just, what the hell, I'll go in and do this. So okay, we have a beautiful setup, but now it's like, okay, these lines are perfectly spaced out. They're just really good looking. So if I go in and manually start extending it and moving it and snapping it, it's just, it's annoying. So there's this conform button. You press on this. So what I like to do when I'm doing just a retopo, strength 100, fall off 100, conform, I just put in 999, whatever the max is. So now you go in and you open up these side options by doing conform options. And I'm going to freeze X and Y and just leave the Z. And now when you press and click on the vertices, it's literally just snapping it only in the up and down direction to the scan. So this is a quick way to take your retopo geometry and just put it on top of the scan. So it's conforming to it, obviously, by the word. But this way, you're spacing your lines, everything's natural, and you're at the same time not having to manually go and do it. So as you can see, the surface highlight is nice and smooth. We don't have that carbon fiber pattern anymore, and we naturally conform to it. So now when I go in, I'm just going to go in and bridge these edges, cross, perfect. All right, as you can see, we're going to add one more, go back to the conform, just click on these, there we go, conform that, bridge from here to here. Now I'm going to go in here, bridge. Now I could either kill it, but as you see, when we turbo smooth, we get some of this penetration happening, which means I'd like to add an edge here. But what I want to do is keep these very same like curvature. So I'm going to do is turn on the edge constraint, hold and drag all the way to the walls until you can't no more. Unclick, and now hold and drag back out. And this trick allows you to have the same exact curve, but move along the lines. And now turn off edge constraint. Now I'm going to go into the conform thing, just like that. Awesome. Snap that in place. Bridge there, bridge there. And now as you can see, we're almost getting no penetration. I don't mind this at all because at this point it doesn't matter. It's not going to hurt us any. The surface is nice and smooth. The edges and bevels are beautiful. It's already holding true to the scan. And it's just, it's awesome. And it's a low res where it's going to be easy to create flanges. Or if you want to at this point go in and start designing your own logos and things, you could do that because the data is simplified. It's not hundreds and thousands of polygons to try to move and adjust. So now what I'm doing is just going in, extending this down, and just kind of taking steps apart. So now, as you can see, I got to copy these edges. So I'm going to go down again, and then this, I'm just going to go in. All right. So just going to go in and bridge these. Let's see. It is flat, so I might be able to get away with. Nope. See, I knew this would be a problem. So what I have to do is kind of create an edge there. That's the only way I'm going to stay true to the top surface of that area. As you can see, I'm getting penetration there just because this is happening. So if I connect an edge there, that fixes it. But as you can see, now we're getting a pinch. So this is what I was mentioning. See how this almost has like an indent and the highlight breaks? In 3D world, that's a pinch, and that's where it just doesn't look good. If I was modeling this for a client for marketing visuals, not for 3D printing or design, I would go in and fix this. Because I could just go in and sand this down and fix it, it doesn't matter. So I'm going to be able to get away with this, but let's see here. I personally, I gotta fix that. I'm not happy with how that looks. So I'm just going to go in. Target weld that. That may fix it, probably won't. Yeah, so as you can see, this floating vertex is no good. So the only other option is, and this is where it gets very annoying, is you got to go in and create a lot more polygons. So I might not waste my time with a video tutorial on this, but let's see here. So this is one way to go about it. So I'm going to snap that to that. Now we have our edge, but as you can see, now we have another edge. Now the way we can get away with this is, see how we have all these corners here? So I could go in and add an edge here. So we could bridge that, and then what I'll do is I'll delete this polygon. This is also not staying true to the scan, so that's perfect. because now I could bridge from there to there and from here to here. Now it sucks because, again, this is where it gets annoying when you have too many edges and vertices to play with or work with, is now you got to really pay attention to the lines being straight and true to the surface. But what it does give me the ability to do now is adjust this one. So there we go. And now in theory we shouldn't have that pinch anymore. Yep, so as you can see now we have a beautiful flow of a highlight. So that's just unfortunately the way to properly fix it. And like here I had a triangle, and I'm not even going to stress over this because this is like a little crevice pocket that I'll be sanding anywhere. Nick will be, not me, because I'm not wasting my time with this. But this is something you can fix easy, and it's in the inside crevice. But this was kind of like an outside corner where the highlight could be seen on the carbon fiber a lot worse than like a crevice. So that's why, even though you could probably get away with it, I just wanted to fix it. Because that's how you got to do it to make it proper, like a proper surface. Because anything you do on 3D prints in real life on the 3D printer, and then you could see those flaws in the reflections of the surface. So if you clear coat your carbon fiber, you'll be able to see it. So there we go, extend that, and there, that's it. So now one other modifier that I'm going to save this so I don't lose anything, that 3D Max has is called symmetry. And if you add this, it literally mirrors your geometry. So what you can do is, if you think your object is symmetrical, you could literally do something like this where you flip-flop it, and then, like, obviously this is asymmetrical on this stuff, but if the other areas are symmetrical, you could try to mirror as much of the work from one side to the other, and then just go in and manually model in the areas that are not symmetrical. So for this project, for me, I am going to try to do that because of how low res the segments are. It's going to be a lot easier for me to flip-flop like this area and like the outside edges, and then bridge them over to the corners that I've modeled in the past. So that's just something to keep in mind when doing retopos, if you could actually do a symmetry modifier and get away with it. So in a nutshell, that's the process of retopoing CAD data or scan data, and there's really not much more to it. Drag and drop, check, drag and drop, clean up, things like that. So I'll pause it or stop the recording here and just kind of do all this and press record when it's done, and kind of give a rundown, and maybe if there's any like things that I ran into that were worth sharing, I'll bring that up. Alright, and here is the final result. So, a little overview. It was a pain in the butt, but worked my way through it. I was able to mirror half of this area right here over on this side, but then had to delete quite a bit of it since it was so different. It was easier for me to remodel it kind of manually than try to salvage the mirror side. The inside, unfortunately, was a lot of just tedious moving around. And as you can see, the idea is I worked my way around the crevices, all the corners, and then kind of extruded the geometry into the middle and worked my way into it. So if you look at the wireframe, everything's kind of has a curve to it, and that's what you want. Is you want to go with the flow of the curvature of the geometry, and that's a whole different topic. It's called polyflow, and that is years and years of just trial, error, and learning, and it becomes kind of like a natural muscle memory in a way. But yeah, no, so overall, happy with the results. This is how it looks smooth. If I show the original scan underneath, it is really like nicely taking shape. This was a little bit like double-sided tape from the old emblem. So I just kind of made it nice and smooth versus having all this like debris. And all the carbon fiber texture is obviously gone, or the fake pattern that it was, because it was all plastic. But other than that, I'm happy with the results. It's much easier to work with than the scan data now. So as you can see, if we isolate the polygons and the edges, it's very minimal, or as minimal as I can make it to still have the true shape of the body. Okay, something weird happened right here. That is no good. So this is what unfortunately happens when there's a lot of stuff going on. Um, it's rare, but it does happen sometimes. So I'll go in and I'll fix this. Yeah, I'll actually, while while we're doing this video, I'll just show a quick little breakdown of like fixing flawed areas. So okay, I'm just gonna delete this. So we'll just extend this one. First of all, let's just go in, isolate these, because I hate all the snapping. The more I modeled, the more it was just very annoying to work with. So I'm just going to extend this one all the way out here, snap it to the bottom, snap it there, like so. Now what I'm going to do, well, I don't have to do it like that. As you can see, here's the edge that we currently have. So move that one over there. This one down here. This. Now to remove a vertex like that, I just select it and press backspace. Press delete, it'll delete the vertex and polygon. Press backspace, it just deletes the vertex. Now I'm just going to bridge that over. I'm going to do a little quick cut. Drag that edge there. Awesome. Now shape this one out. Something like this. Alright. Now I'm just going in and bridging across. We're going to cut an edge into that. There we go. I'm going to connect this. And let's see if I can get away with something like this. There we go. Alright. Now I'm going to cap this one. There we go. Beautiful. Alright. And now, last but not least, is just to really close it all off. So I'm just going to try to bridge that there. Alright. And now let's just take a look at the whole surface. Make sure there's no weird pinching or crazy bumps. There we go. So as you see, it's very quick. Like once you actually get comfortable with the techniques, you could fly through the fixes and changes. So in a nutshell, that's that. I'm seeing some curvature here that looks a little out of place. So what I'm going to do, just go into the snap thing. Maybe confine it a little bit more. So that's what you do want to do, is just double check all the areas, make sure there's nothing bizarre happening. So there you go. I like that more now. It has a better flow. And so that wraps up this little breakdown tutorial of rotoscoping scan data and creating a brand new mesh out of it. So now I could in 3D Max, so I'm going to save this now that I fixed that other side before I do anything else destructive. There's a modifier called shell, and what I usually like to do, so I'll add a smoothing group of 1. And let me move this over. So right here, there's these things called smoothing groups. So if you put a smoothing group of 1 on the whole thing, so make sure you click clear all when you select everything and then press just 1. And the reason for that is I'm going to add a shell modifier. And this is for the 3D printing stage. If you want to do like a test print to make sure your part's good before you actually, make the mold or whatever. So typically I like to do at least 3 millimeters. It just gives it enough thickness, and I'm going to do inner amount, so it moves it on the inside. So 3 millimeters. Now when you do turbo smooth, as you can see, all the edges are gooey. Now to fix that, all you have to do is press smoothing groups, and it's going to separate the surface that we applied the one to versus the inner edge, which is automatically assigned a different smoothing group. So now we have our crisp edges holding true. So if we unhide the scan data, as you can see, now it's feeling a lot more natural to the actual geometry we scanned. And now you can 3D print this part. If you're going to do a mold, you still want to use shell. At least that's what I've been using. But what you will want to do for that is actually model the flanges and then do the shell. So I'll do another video tutorial on modeling flanges, and I'll do it for this one in particular because this is the one that my buddy wants a 3D printed mold of, or he's going to do the 3D printing and the mold processing. I'm just helping him get the 3D model of it. So I'll do a video tutorial on modeling the flanges, but that's a whole different topic of its own, and that's just a matter of user experience with compositing and figuring out what's best for laying down the carbon fiber and such. Since I am still new to the compositing thing, I still learn as I go, but I'm starting to get the hang of where I want the flange and how big of a flange I want. So I'll start that tutorial next, but in a nutshell, this wraps up the Retopo version of it. So hopefully it helps somebody.